Okay. Brittany randomly surveyed 50 students and found that 20 had a part-time job. If there are 810 students in Brittany's school, predict the total number of students with the part-time job. So there are two things that we are talking about. We are talking about the total number of students, and we're also talking about students with part-time jobs, right? So when you're setting up your proportion, you want to make sure that these two items are either horizontal or vertical. So let's first talk about horizontal. And so when we talk about horizontal, that means we want total on the top and part-time jobs on the bottom. So it says that she surveyed 50 students and that 20 of them had part-time jobs. So this is our ratio, 50 over 20. So then it says that there are 810 students in her school, and she wants to know how many have part-time jobs, or make a prediction about how many have part-time jobs. So in this instance, we have our setup to be horizontal, in that the totals are on the top, part-time jobs on the bottom. You could also have the setup be vertical. And so when I say vertical, I mean that the total number of students that she surveyed was 50. There's a total of 810 students in her school. When she surveyed 50 people, 20 had a part-time job. How many have a part-time job when she surveyed 810? So now my totals are in the first column, part-time job, in the second column, right? So then, regardless of either one, my equation when I find the cross product is going to be 50x equals 810 times 20. That hasn't changed. Okay, but it's important that you make sure that your things are lined up where they're supposed to be. And that's the same thing we're going to have to make sure of when we are looking at similar polygons, that we have either, and we'll look at that in a second. Let's not get that far. But so anyways, this is your equation, regardless of if you have a horizontal setup or a vertical setup. So then 50x is equal to 16200. And then if I divide both sides by 50, x is equal to, that goes in 3 times, 5 goes into 12 2 times, 12 goes into 24 times, 324, right? So approximately 324 students have part-time jobs. Do we have questions? Do you guys understand what I mean by horizontal versus vertical? Okay, perfect. Let's go on. All right, so now we're talking about similar polygons. So I got to go back real quick. Now we're talking about similar polygons. Two polygons are similar if and only if their corresponding angles and if their corresponding angles are congruent and corresponding side lengths are proportional. So looking at these particular figures, A is congruent to W, B to X, C to Y, D to Z. Those are our angles. They're congruent. However, our sides are proportional, which means you're going to have two shapes that look the same but are different sizes, basically a big one and a small one. Okay, so AB is AB and WX are proportional. BCXY, YZCD, ADWZ. Okay, and if you look down here in the bottom where it says symbols, it says ABCD is similar to WXYZ. So that little squiggly mark that looks like this, that's going to mean similar. Okay, and so remember, congruent looks like this, right? So our similar is just the squiggly that is on the top of the equal sign. All right. Questions? Okay. All right, so scale factor. The ratio of the lengths of the corresponding sides of two similar polygons are the scale factor. So the scale factor depends on the order of comparison. So you always want to pay attention to your order of comparison. So in this particular case, we know that ABC is similar to XYZ, and we can see that right over here because that's what it tells us, that they're similar. Okay. And so then notice that our scale factor for the first one is asking us to go from ABC to XYZ. ABC to XYZ. So that means that our scale factor is going to be 2 because we're going from ABC to XYZ. So AB is 6, XYZ, XY is 3. So 6 over 3 gives us 2. In the second one, we're going from XYZ to ABC. So XYZ, XY is 3, AB is 6, so 3 over 6 is a half. Okay, any questions? All right, next. So in the diagram, RST is similar to XYZ. So we need to find the scale factor, list all the congruent angles, and then write the corresponding ratios. So I'm going to give you about 1 minute to do that. 1 minute. All right, so let's take a look. So we're going to actually look at these a little bit out of order. I'm going to start with number 3 or number 2. It says list all the pairs of congruent angles. So we're going to start there. So we know that angle R is congruent to angle X. Angle S is congruent to angle Y. And angle T is congruent to angle Z, right? And we know that automatically because we can read a similarity statement just like we read a congruent statement, okay? And then it says, write the ratios of the corresponding side lengths in the statement of proportionality. So we know that RS and XY will be equal to ST and YZ, which is also equal to RT over XZ, right? So then once we have the actual proportion for the sides, then we can add numbers. So for RS, we have 20 over XY, which is 12, and ST, which is 30 over YZ, which is 18, and then RT, which is 25, over XZ, which is 15, all right? And so if I take each of these fractions and I reduce it, then I end up with 5 over 3. So then my scale factor is 5 over 3. Questions? Yes. Are you asking a question, Ty? Huh?
We're going from RST to XYZ.
Yes. Because here.
So wouldn't that mean it'll get smaller?
Huh?
Wouldn't that mean it'll get smaller?
Okay, so when you're looking at, you have to go in your order for your similarity statement. And it's so weird that it's always going to be, I don't know how to explain it, but you always, if your similarity statement goes from, you have to always follow how it goes. So you have to start with RST to go to XYZ. So whatever the order of your similarity statement is. That's the only way I know. And it's always going to seem backwards. It is.
No. 18 is 3/5 is 30, right?
Yes.
So wouldn't it be 3/5?
Huh?
So wouldn't it be 3/5? It's like
but you have to go in the order of your similarity statement. This. So it's always this one compared to this one. I totally understand what you're saying. Don't get me wrong. I totally understand what you're saying, but you still have to go in this order. Like, I understand. I get your logic 100%, because that will make sense to me too as well. But when we talk, we'll get into it in our next unit when we talk about transformations. Anybody else have any questions? All right. Okay, so in this diagram, triangle DEF and triangle MNP, what's the scale factor? Find the value of X. So I'm going to give you about 1 minute. Okay, so when we look here, it says triangle DEF is similar to triangle MNP. So what's the scale factor? Oh, sorry, y'all. So what's the scale factor? Okay, so the similarity statement is giving us our order of comparison. So we need to find the value of X. All right, so if I'm using this statement, then I know that DE is similar to MN, and EF will be similar to NP. I don't know why this is skipping. And then DF would be similar to MP. And then I'm going to set this up. Let's see, DE is 15. EF is X. DF is 20. And then MN is 18. NP is 30. And MP is 24. So I can choose to pick either these two or these two. All right. So I'm going to just go with the first two just because they're the first two. So 15 over 18 is equal to X over 30. I can reduce 15 over 18, right? I can reduce 15 over 18. 3 goes into 15 5 times. 3 goes into 18 6 times. So that gives me some smaller numbers to work with. So now I have 6x. 6 times x is equal to 5 times 30. So 6x is equal to 150. And so x will be equal to 25. Okay, so then what's the value of x? X is 25. What's going to be my scale factor? Well, I have 15 over 18, which reduces to 5 over 6. I have 20 over 24, which also reduces to 5 over 6. So my scale factor is 5 over 6. Because that is my order of comparison. Okay? Questions? Next. So here's triangle TPR, and it is similar to triangle XPZ. And we need to find the length of the altitude, which is PS. So I'm going to give you about a minute to find the length of PS. All right, so when we look at triangles, we can also look at the parts of the triangle to say that those parts are proportional. So it is asking us about the altitude, which is PS. So all right, so it is asking us about the altitude, which is PS. So I'm going to start with PS. So I'm going to start with PS so that I know what I'm looking at. So PS is in the triangle on the left, and I'm going to compare it to the one side of that triangle that I know, which is TR. And then the same portion that is in the triangle on the left, that's PS, is going to be PY on the right. And TR is going to correspond with XZ on the right. So PS we don't know. TR we know to be 12. That is equal to PY, which we know is 20, and XZ, which is 16. All right, so 20 over 16, I'm going to reduce that to 5 over 4. Give me some smaller numbers. So 4 times X is equal to 12 times 5. So 4X is equal to 60. So X is equal to 15. So my length for PS is equal to 15. Questions? All right. So now let's look at the next card. All right, so if two polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths. So basically, the perimeters work just like the side lengths in that the perimeter is going to be just as proportional, which makes sense because all you're doing is adding the sides together. So perimeter is proportional in similar polygons. So a town plans to build a new swimming pool. An Olympic pool is a rectangle with a length of 50 meters and a width of 25 meters. The new pool will be similar in shape to an Olympic pool, but will have a length of 40 meters. Find the perimeter of an Olympic pool and the new pool. Right, so we're talking about perimeters, so they want us to use perimeter. So we know that in the picture that you see, this is going to be your Olympic pool, right? So what's the perimeter? So what's the perimeter? Where's my mouse? Okay, what's the perimeter of your Olympic pool? That's going to be 150, right? And that's the perimeter. So then we need to figure out the perimeter of the new pool. So the perimeter of the new pool is what we don't know, so we'll call that X. But what we do know is the diameters of the dimensions, I keep wanting to say diameter, the dimensions of this pool is 25 by 50. So 25 by 50. And so then they also tell us that the new pool will have a length of 40. And so in this particular case, 50 is the length. So then my new pool has a length of 40, right? So I need to now find the width of the new pool. Let's call that Y. Right? Okay, so 25 over 50, we can reduce to 1 over 2. So I have 2x is equal to 40. Or, oops, 2y. I made that a y. 2y is equal to 40, so y is equal to 20. So the width of my new pool is 20. So my pool is going to be really a 20 by 40. All right, okay. So if I know that my Ratio for the side lengths of the old pool is 1 to 2, then how can I use that to help me figure out what my perimeter is? Aside from, I know that I can add it together, right? This is 60, the other two will be 60. But we really want to be able to use the perimeters of similar polygon. So what could I do that could help me? So I know that the length is 50 for one pool, and the length for the other pool is 40, my new pool. I know that the perimeter for the Olympic pool is 150. I could use that to help me find the perimeter for the new pool. So really what they want you to know is that your setup can include perimeter in your proportion. Okay, and so then we know that X is 120. Okay. Questions? All right, almost done. Now we gotta look at area real quick. And that will be it. All right, so your card number 98 says if two polygons are similar, then the ratio of the areas is equal to the squares of the ratios of the corresponding side. So if I have two polygons and I know that PQ is similar to KL, I know that PQ is similar to KL, then PQ over KL squared is going to be equal to the areas. Okay. So in this particular case, I have A, B, and DE that I know are similar. So I'm going to look at AB, and it is similar to DE. And I can compare those two squared to the area, which the area for the one on the left is 36, and I don't know the area to the one on the right. So AB is equal to 10. DE is equal to 5. And those are going to be squared. All right, so that's going to be 10 squared is 100, 5 squared is 25, and that is equal to 36 over X. So 100 over 25 can reduce to 4 over 1. So 4X is equal to 36, and then X would be equal to 9. So I used my sides to compare with the area. So I used my sides to compare with the area. Questions? All right, that is it. You don't have an assignment to do tonight. We will work on that assignment when you come tomorrow. We'll work on that assignment when you come tomorrow. So you don't have anything that you have to do. And then also